Hello, 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 and welcome everybody to math class. Good morning. It's Mr. Taco. Reminder, up here, there, is the title of today's lesson. We're working on division as a review. Today, you're going to need those things over there. So if you don't have them, please take a minute and go get them. You will need something to write on and something to write with today. Those tend to be the easiest. And then down here are today's I cans. I can follow a lesson on YouTube, and I can use the standard algorithm to divide a multi-digit number. Okay, thank you again for joining. I'm glad to see there's a number of people in watching live right now, which is great. So let's get into it with this idea of division. Yesterday, we talked about multiplication as this idea of making groups of a certain number. If it's 6 times 9, we're making 6 groups of 9 and figuring out what the total amount is, or our product. With division, it's the inverse operation to multiplication. So just like addition and subtraction are inverse operations, multiplication and division are inverse operations. They do the opposite thing. Okay. Multiplication takes a certain number of groups of a certain size and figures out how many total. Division takes a total and gives you groups of a certain size and figures out how many groups those are. Okay, so in this case, we've got 54 dots here. And we're going to try and figure out how many groups of 6 those 54 dots can be put into. Okay. With division, equal groups is paramount. If you're not making equal groups, then you could have any number of groups from 1 to 54 because the groups don't have any meaning because they don't equal something. But we have to have an equal or a standard group that we're working with. In this case, we're going to work with groups of 6. Now, these 54 dots are kind of spread out all over the place. So it's going to take me a minute to make my groups of 6. So hold on. Bear with me just a second. Okay, there's my groups of 6. Now I'm going to count up how many groups I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 groups of 6 makes 54, which we proved that yesterday. In fact, when we talked about multiplication. But now we're taking those 54 dots and we're dividing it by 6 to make 9. The other way you can think about it is 54 divided into 9 groups with 6 in each group. Both of these equations are true. The thing about math is we not only want to be accurate, we want to be efficient. We want to do things in as few steps as possible. And as our numbers get bigger, it becomes way, way, way super inefficient to draw out the total number of dots that we're going to need in order to divide them. We need to get a little bit more streamlined. Let's use our friend, the rectangular array, again. So here, we've got those same 54 dots, but now they're organized in such a way that lets us see those divisions clearly. Okay, if we're thinking about groups of 6, we've already set it up to have 6 rows and 9 columns. So we can already see, 54 divided by 6, that's just going to be the number of columns I have. 54 divided by 9, that's just going to be the number of rows I have with 9 in each row. Here's our area model. We used it for multiplication last time, right? With our 9 on the top, 6 on the side, and then we figured out our total in the middle. With division, it's a similar process because, again, they're inverse operations. They're related. So 54 is our total area. 6 is the number of rows. And then we want to figure out what's on top. And for any parents or grown-ups watching this, this is why our long division sign looks the way it does, because we're really thinking about it in terms of the area of a rectangle. And if we were to do that math, just like up here, here's our 6, our 54 total, and then our 9 rows on top. Now, as the numbers get larger, just like with multiplication, what we're going to want to do is we're going to want to use that expanded form to break up our larger numbers, or our dividend, the amount that's being divided up. We want to break up that dividend into smaller pieces to make them more manageable. So our sort of demo problem for today is going to be 492 divided by 3. Now, obviously, we could draw out 3 rows with a certain number of columns to make 492 total, but that would take quite a long time. So we're not going to do that. We're going to take a little shortcut, and we're going to use our expanded form, and we're going to use that area model to get us to and help us explain what exactly we're doing when we talk about the standard algorithm of division. Ta-da! There it is. So when we're talking about the standard algorithm of division, we're talking about any division problem, 492 divided by 3, or 492 divided by 3, or 492 divided by 3. All 3 of these statements, all 3 of these expressions deal with division. They're all the same problem. They're just written in a little bit of a different way. And you might notice, wait, Mr. Taco, that looks like a fraction. You're correct. It is a fraction. Fractions are division. Division is fractions. You're just dividing one thing up into some parts. Okay, if it's a fraction that's less than 1, you're dividing 1 into some parts. You're dividing 1 pizza into 8 parts. So each part is worth 1/8, right? So for 492 divided by 3, before we get to the standard algorithm down here, let's take a look up here at our area model. So I've went ahead and given us a start of dividing this up into our place value in expanded form. So 492 being 4 hundreds, 9 tens, and 2 ones. And then we're going to think about, if I have my 4 hundreds, if I have 4 things, each of them worth 100, how many groups of 3 can I make? I can make one group of 3. 100. And then what we want to do when we're dividing something out is we always want to subtract until we run out of things to divide. Okay? So if we are using this area model to say this rectangle is 100 times 3, we have a total of what in this rectangle? 100 times 3? 300. So we're going to subtract that 300. 400 minus 300 equals 100. And then what we're going to do is we're going to move it and we're going to add it to our tens. So 100 plus 90 is 190. Now, the other way we can say 190 is 19 tens. So now we want to think about, if I have 19 tens, how many groups of 3 could I make? Maybe you're familiar enough with your times tables of 3 where you can go, well, what's 3 times something that's less than 19 but is close? Or, let's Just count by threes. There's no harm in counting by threes. 3, 6, 9, 12, 15, 18. Well, I can't go past that. The next one's 21. So it must be 6 tens. Because we're in the tens. It's always going to be 6 tens, right? 3 times 60, if we're thinking about this rectangle as being 60 wide and 3 tall, right? How many are in that rectangle? 6 times 3 is 18, and use our multiples of 10 shortcut to make 180. And then we subtract that out because we've already figured out how much 60 groups of 3 is, so we need to know how much is left over that we still have to divide. 190 minus 180 is 10. We're going to take that 110 and we're going to move it just like we did here to make 12. And if we have 12, how many groups of 3 can we make with 12? 3, 6, 9, 12, with no remainder, which I did on purpose because it's the demo problem. So we end up with 164 as our total. So if you were to draw out, if you were to take 492 dots and put them into groups of 3, you'd end up with 164 groups. Okay, we're noticing now how this division and multiplication model, they look really similar, huh? Except with division, you know what's in the middle, you know the area, you know one of the sides, you don't know the other side. Versus with multiplication, you know both sides, but you don't know what's in the middle. Now, how does that apply to our standard algorithm? I'm going to go full screen here so we can see nice and big what we're doing. So if you have 492 divided by 3, it's no different than what we just did up top, except it's a little bit shorthand. So we start with our hundreds. We say, how many groups of 3 can I make with 4? Well, 3, 6, that's too many, so just 1. 3 times 1, and the hundreds here, that's the implied part. That's the shortcut to standard algorithm. We're not saying that it's actually 100. We're saying it's one group of 100. So 1 times 3 is 3, and subtract, with 100 left over. Then, rather than how we took our 100 and we added it to our 9 tens, this time we're going to bring our 9 down so we can then divide the next piece, our tens. So again, how many groups of 3 can we make with 19? 3, 6, 9, 12, 15, 18. We put our 6 above the tens place. Important to keep them lined up. Okay, that's really going to help out. We end up with accuracy errors when maybe our 6 is over here and we're all of a sudden, oh, I guess I'm done, right? Really think about keeping our places lined up here. 3 times 6, we just did it. 3, 6, 9, 12, 15, 18. With 1 left over. Then we're going to bring our 2 down because we have 12 left. How many groups of 3 can we make with 12? Well, we can make 4. 3 times 4 is 12. 12 minus 12 is 0, so we don't have a remainder. Now, what if it were this? And instead of a 12, down here it was a 13. 3 times 4 is 12. 13 minus 12 is 1. We have 1 left over. Can I make a group of 3 with my 1? I'd have to break it into fractions to do it. Okay? So one way you can write this answer, if you had 1 left over, is you could write it remainder 1. There's 1 left over. Or if you were feeling a little ready for fractions, you could think about, okay, if I have 1 and I break it into 3 pieces, how much is each piece? It's a third. So we can say, where'd my eraser go? 164 remainder 1, or 164 and 1/3. Both answers are equivalent. Both answers are acceptable. It's all a matter of, do you want to express it as a fraction, or do you want to express it as a whole number remainder? Both make sense, and both are mathematically accurate. All right, let's try a couple of practice problems. So get your something to write with and something to write on ready. We're going to move to our digital whiteboard, and our first practice problem of the day is 78 divided by 3. So think about, if we're setting up our standard algorithm, we're going to make our area here. I went with a purple pen. I got some feedback yesterday that the rainbow pen was a smidge distracting. So we're going to go with the purple pen today. We're going to put our 3 on the side, and then our 78 in our area space, and we want to know what essentially what the length of that side is on top. Okay, so let's think about 3. How many groups of 3 can we make with 7? How many groups of 3 can you make with 7? If I were to draw it out over here, let's say each of these is one of our 10s. How many groups of 3 can we make? There's a group of 3. There's a group of 3. And we can't make another whole group of 3, and that's okay. So we have 2 groups. 3 times 2 is 6. 7 minus 6 is 1. And then we're going to group that 110 in with our 8 ones. So we have 18 left to divide. All right, if you want to imagine this in word problem form, let's say we had 78 red vines that we're handing out to 3 friends. So far, we've handed out 20, or 2 10s, 20 red vines to each person. So we want to know how many we have left to divide out. So if we've given 20 to each person, 20 plus 20 plus 20 is 60. So we have 18 left. All right. So now, how many groups of 3 can I make with that 18? Don't be afraid to count by 3s. 3, 6, 9, 12, 15, 18. There's our 6 groups of 3. 3 times 6 is 18. We have 0 remainder. Okay. Should we try one more? Let's try one more. I'll give a little bit of time to see if your answer matches mine. I don't want to erase too quickly, even if it's not the most engaging video. Let's try one more. And let's try one here where maybe that first digit that we have, you can't actually divide up. So let's try this. Here's our division sign. Let's try 187 divided by 6. So take a look at our 100 here. Can I divide this 100 into 6 parts? Not yet. Not yet I can. It's actually going to be easier rather than trying to go, oh, what's 1/6 of 1? Right? Instead of doing that, let's just fold it into our tens. We'll incorporate it into our tens. So now we're looking at how many tens we have. And there's our 18 tens. Let's think about how many groups of 6 can I make with 18. Again, don't be afraid to count by sixes. 6, one group of 6 equals 6. 2 groups of 6 equals 12. 3 groups of 6 equals 18. Stop. There it is. 3 groups of 6 equals 18. The important thing here is make sure, because we're dealing with the hundreds and the tens, we're going to put our 3 over the tens place. Because we're not dividing 18 hundreds up into groups of 6, we're dividing 18 tens into groups of 6. So we're giving 3 tens to each group. Okay, if we put it over the hundreds place, that makes our answer quite inaccurate. Okay, now let's do our subtraction. 6 times 3 is 18. 18 minus 18, that's 0. And then we have our 7 left over. How many groups of 6 can you make with 7? If I have 7 slices of pizza and I want to give 6 slices to a friend, how many slices will I have left over? So we have one group of 6. 7 minus 6 equals 1. Now remember, there's 2 ways you can write this. If you have 1 remaining, you could either write it as remainder 1, R1, or you could write your answer as 31 and 1/6, because you're taking 1 remainder. If I draw it out like this, zip, zip, and you're breaking it up into 6 pieces. So if you're going to make a group of 6, it's 1/6 in each part there. Okay? If there was a remainder of 2, your answer would be remainder 2 or 2/6. Okay? Your divisor, the thing you're dividing, that's always going to be your denominator in your remainder if you're writing your remainder as a fraction. Otherwise, you can simply write your remainder just as a whole number with an R in front of it is fine too. Makes sense? So remember, everybody, that after this video is over, I will be in our class Zoom room. If you have questions or if you'd like feedback on your answers, please, I welcome you. I would love to see you in the Zoom room. So come on in, hop on your device, come on into our regular Zoom room that we use for every other meeting, and ask away. Your exit ticket is on Google Classroom now. It is due at noon today. Unless you're watching on replay, then it's due as soon as you can. Reminder, 2:15 is our closing meeting today, so I hope to see you there. Thank you, everybody, for tuning in. Have a wonderful rest of the day, and I will see you on this page on Thursday for our next YouTube math lesson. Take care.